All right, so this is where we left off with yesterday, correct? This is where we left off with? Okay, so now, yeah, one step ahead, that's where we would start, but this is where, was this up here yesterday? Okay. Okay. Right. So next week, okay, next week we'll start talking about this, okay, because we said usually, at least verbally, I try to tell you what it is we're doing. I have a general idea. It's written up there. We'll start talking about acceleration on Monday, okay, and it says assign vocabulary chapter 2, which is due on 8/26 or August 26th. So some of you might have your vocabulary done. Typically that's what students have done in the past. They've just gotten started as soon as I've handed them out. Then maybe 1, maybe 2, maybe 3 days later, I just formally assign it and say, okay, if you have it done, heck, one less thing to have to worry about, right? And unfortunately, maybe like for your parents, when it comes to filing taxes, I don't think you would know this, but you might. When can you file your 2020 taxes, do you think?
July. No, it's July.
Well, you can start working on them, but when do you, I believe I'm right, but when do you think you can actually file with the Internal Revenue Service or IRS? You might have it done, but when can you actually file it? Probably January 1st of 2021. So we're a little bit behind. That you're always 1 year behind, so you will file, no, you're going to file your 2021 taxes, sorry. January 1st of 2022 is the earliest that you can file your 2021 taxes. But does that mean that you have to have them filed the first week of January? No. Do you know when approximately the deadline is? No. Well, for this year it is, yes. But typically, it's somewhere in April.
April 1st?
Close.
2nd?
April 15th. You know, if you had, next time you look on your phone, like for instance, I can do this. I can get mine out quickly, just as a visual aid. So I got my calendar open. So if I go up to and find April 15th, what does it say up there in the green?
Good Friday.
Good Friday and what else?
Passover.
And tax day. Although Good Friday is probably considered as a holiday, so it might not, I don't know when for sure that would be, but April 15th is when your taxes have to be filed. So what that means is you can start working on them. You can file them in January, February, March. If you have them done, it's just one less thing to have to worry about. Okay? We try to get them done in February. Then it's just one less thing to have to worry about. Like, I don't know. Anyway, so this is where, again, we had left off with yesterday, and we'll start talking about this on Monday. All right? So for perhaps the remainder of the time, I got a little bit of information behind this screen, and I'm looking for my slide presenter, which is right here. Okay? I suggest you write this down, but I'm not going to go up and down the aisles. You're in high school now. Okay? If chances are, if we're writing something down on the board, there's probably a pretty good reason why you should write them down. Okay? So these are what are examples of story problems. So we constantly work on these from here until December. They're just different types of story problems, okay? Do what?
Write these questions down.
Yes. And leave a little bit of space between them, okay? So it says an alligator leaps out of the water at 12.63 meters per second. A wildebeest is drinking a little bit of water, and then as it lifts its head, it's approximately 1.35 meters above the water is this wildebeest's head. Okay? What is the time frame of this ambush? So in other words, as that alligator jumps out of the water and grabs a hold of this wildebeest in 1.35 meters, how long in time, not in distance, how long in time and seconds did it take to grab that wildebeest? Okay, so go ahead and write that problem down and then leave maybe 4 or 5 lines and then write the next question down where it's talking about Keynesian or hurdles. So this is what we mean by problem solving, okay? And you have problem quizzes over these, and this is a separate portion of the exam. Like for instance, this would be part 2 of an exam. Part 1 is, for instance, that vocabulary that you're working on, and general multiple choice questions is part 1. Phew. Probably not very smart to be drinking coffee on a hot day, is it? No one said that we're geniuses. Yeah. Oh well. Yeah, that's quite possible. And then this is where that formula that we told you to write down and make a formula sheet, you can use that formula to help you solve this problem. I don't expect you to memorize these, okay? I want you to be able to apply that information, not memorize it. And then, I don't know if last year really, I think they liked this idea. Sometimes in between the review of the exams and then the part 2 story problems on the Science Channel, and then watch it, don't watch it. It was entirely up to them. They had requested it. If you think you can solve them, yeah, we're gonna solve them, but I didn't know if you want to do it together as a group or do them on your own. The bottom one is much, much easier than the top one. I mean, they're both using the same formula. It's how you get to that point that's just a little bit different. This is where you get to use your algebraic skills. I'm sure Ms. Doctor would say we all have good algebraic skills. Is that accurate? No? Okay, well, we'll do our best then. And if probably when I was sitting in your chair on your side of the desk instead of mine, you wouldn't be wrong sitting there saying, why do I got to do things like this when it's not so much that you're ever going to use this information, but how many of you actually have a general idea of what it is you want to be doing past high school to support yourself in a type of career? Okay? And let's say maybe it's something in the medical field. I just use that a lot because of the science class. You probably have to take classes like this even if you're just going to go, oh, I want to be a nurse. Well, that's great. You're still going to have to do problem-solving classes like these in college. That's just the way it is. Can't change that, but so it goes. Does everyone have these problems wrote down or written down that wants them? Can we go forward? Okay, let's do this bottom one in purple first. Okay, so it says Kenzie's running her 300-meter hurdle. She said, what, 48 seconds? Yes. This is what I highly, highly, highly recommend that you do. Okay? Once you've read the problem, do what's called a setup. A setup is just writing down the information that you know. Okay? So what information do we know from that story problem? We know how far she ran because the race is what distance? So the distance was 300 meters. Okay? So when she ran this particular race, how long in time did it take her to complete that? 48 seconds. Okay? And the reason this is so important is when you get a lot of information where a lot of these story problems start tying into one another. Heck, maybe there's about 6 to 7 lines of material. Once you have a setup, you don't have to go back and read in the problem because you've accounted for that down here. Then the last thing that we want you to do, what is the question asking? What was her velocity? So then you just put V. Well, we don't know what that was. That's what we're trying to solve. That's exactly what you're going to do because once you get to this point, what does the formula tell you to do? What does velocity equal? Okay, so according to that formula that you wrote down, velocity equals the distance, which again, you don't have to go back and read your problem. You've accounted for it right here. Nearest hundredth, 2 decimal places. Yep. So it says the distance gets divided by the time. And you don't have to put these labels in here because you've accounted for those labels over here in your setup. That's why we want you to do the problems in this manner. Okay? So now, what was her velocity? 2.5?
Yeah.
6.25, but excuse me, too much coffee. Now we need to put a label on there. How do you label a velocity? Meters per second. Then you can put a box around that and say, yep, I've got the answer. Now, spend time and do this right, okay? Because a lot of these concepts are going to start to build upon one another. Not this chapter, okay? But when we start talking about power, horsepower, work, forces, accelerations, all of them are going to start building around this principle. You will not get away from doing velocities until the end of the semester. We're starting here in the first week. You will constantly use this concept all the way through your semester exam. Okay? Now, take advantage of those easier problems. Not all of them are going to be this simple. Well, I'm sorry. Maybe that's not simple for everybody. We might not read as quickly as somebody else. We may not interpret things as well and quickly as other people. But that's why we work on these together. So that way, should you have a question, you can address those issues. Okay. Do you want to try to work on this one on your own, or do you want to do this together? On your own. Okay? So go ahead and take a few minutes, and we'll see once what you receive for an answer. Okay, yep, sound is still working. All right.
So they already gave you a velocity.
So I suppose I can actually hit pause here on the recording, so we're just not sitting here just do. Okay. Now we've taken a few moments. Now, you've read the problem, and some of you have solved it already. Good. What did we do down here that you should do here? What's the first thing you should do after you've read the problem? Okay. So what do we know in this problem? What do we know? Well, we don't. Yes, you do, but we're not that far yet. You're about 5 steps ahead of us, which is good, but let's make sure we get there first. What's the first? Because some of you had said it. I'm just waiting for you to give me that information that we should write down. Okay, so we know the distance, which is what? 1.35. Is this showing up? It's kind of, I think you can see it out on the recording. So we know what the distance was. What else do we know from here? We know the velocity, okay? And you're correct when you say that, but how did you know that this was a velocity? Meters per second, because when we get further down into this curriculum, it's just human nature. Not everyone's going to be perfect. Human nature, people are going to do this. There's going to be a number that's labeled in meters per second squared. This is an acceleration now. And sometimes that mistake can be made. They put this in for a velocity instead of an acceleration. But if it's meters per second, it's a velocity. Okay, notice in this problem, we were looking for the velocity. This one, we've got it, so there's one variable that we're missing, which is what? Your time, okay? Now, here again, you're using your algebraic skills. Now that you've got your setup down here, we just have you do what that formula tells you to do. Where does the velocity go in that equation?
In the front.
On the left side. That's why I'm presuming you mean by front. 12.63. We don't have to label it because we did that over here. What goes on the right side of the equation? And what was our distance? Okay. You can put any variable down there. You can put y, x, c. Since we're looking for time, we'll just use the variable t. Now, in this case, this is where you use your algebraic skills. There's 2 ways you can approach this. Okay? Should we try the simplest, that what would make the most sense, that I would presume would be best for you? If you take any number and you put that number over 1, have we changed that value? No, you have not. Because if you take 12.63 and divide it by 1, you get 12.63. So nothing has changed. So rather than having a fraction over here, a number and a variable, we can get this into a nice linear equation by cross multiplying. Okay? In other words, if we take 1 times 1.35, what do we get? We cross multiplied. What do you suppose happens if you take a number times a variable? Right, you get that number and the variable. So 12.63 times your variable gives you 12.63 t. Okay? Now you're home free. How do you get that variable all by itself? Yes. Divide each side by what? Got 12.63. So if we divide this side by 12.63, what do we got to do to this side?
1.35 divided by 12.6.
And then you don't have to show this work, just get it into this form, but these two numbers cancel each other out, so then t will equal whatever those are divided by each other. 0.11. So time equals 0. And if you don't put the 0, I just always do. It's just a habit. So 0.11, and what's the label for that? Nope.
Time.
Yeah. Time is the variable, but what's the label for the time? Seconds. Yep. All right. Isn't it nice you get to do algebra in this class? No. Well, that's the goal. Right. Okay. The reason that this might be a little difficult is because this is new to you. Okay? Typically, when you get a math assignment or an algebra assignment, maybe you just get the information here. It doesn't have any words attached to it. It doesn't have any variables attached to it. You just get the equation of the problem. It just says solve for t. Okay? The only difference between what you're doing there is it's actually in a word problem. You do story problems in algebra anyway, but maybe nothing to this extent. We try to make it somewhat interesting. Why would you want to say, you have a distance of this in a time, what's the velocity? Kind of boring, isn't it?
Yeah.
Be easier to understand.
Maybe. But this helps you with your English so you speak it gooder. Yeah. Speak it gooder. Or goodly. This is very goodly. All right. Questions? Are we on the bus?
I see a symbol.
What that means, if I ask, are you on the bus? That means, do you understand? Okay? So what I used to be able to do was I had 5 columns in here. I could say, like, I know this is my right, but it's your left. I would say left outside, left middle, middle, right outside. But in this case, so left column, nodding your head yes, means that you understand this. That way you don't have to raise your hand. No one's really seeing whether you understand or not except me and maybe your neighbor. So left outside, do we understand this so far? Until we all nod, I don't move on. And if you say no, that's fine. That's something that we help you close that gap. Okay, middle. Okay, right outside then, or right side. Right side. Right side. Okay, there we go. When I say that about 2 or 3 times and someone says, hey, ask you a question, or wake up. So, all right. So that's enough for tonight. Go ahead and use the rest of this time to work on your vocabulary or something to that effect. We'll catch up to you next time.